Good morning, everybody, and welcome to today's webinar. Part of a series that we're doing on modernizing your wireless network. And today, kind of what we're going to be looking at is modernizing your wireless network when we are doing this for reliability's sake. And so we're going to go ahead and get things kicked off. This is also going to be available up on the website under basically the modernization section that we've created, which I'll show you a little bit later on as we get towards the end. But as we kind of look forward on this and start to get things going, really what we want to look at is kind of across the board, a lot of the industries that we're involved with. This is your water and wastewater, oil and gas, mining, material handling, power and energy, agriculture, infrastructure, factory floor, the AGVs. A lot of the heavy industries is really where we tend to be installed, where we really kind of have our home. And really across the board with all these industries, what we're seeing now is this digital transformation. Now, when we start looking at the digital transformation, really where we're at now is up in this industry 4.0. We've now really kind of evolved from being a serial-based communication scheme in which it was device to device, say a PLC to a PLC, something of that nature. And so now we're basically have now evolved into the Ethernet world. So not only is the data itself differently and the timing of that, but really the big portion of this is to get networkability, right? So now it's not a device level, but we're bringing everything into a common network of whether that be the IT-OT combination or an OT network and an IT network, but we're really now at a network level as opposed to a device level during this digital transformation. So when we look kind of at this connected or networked model, what we start to see here is that we've kind of got our things that would be out there on the left-hand side. These are things like your PLCs, these are the devices. And then ultimately what we're trying to do is to get it over to that far right side so that we can analyze that data, we can actually make some sort of actionable item out of that data. This can be for machine learning, visualization, automation, and in between this thing, so we need to have connectivity, and then we need to basically have that data storage itself. So we need to essentially be able to get the information out of those remote assets, get it in, store the data, and then analyze that, right? So as we kind of take this now of that connected network, there's really kind of these 7 must-haves that we look at. So really what we're looking at is it's got to be reliable. You know, that's really kind of the key, and that's really where we're diving into this today. We've got to have persistent data acquisition. We've got to have edge-to-edge cybersecurity. That's another section that we'll cover. Needs to either be layer 2, layer 3 compatibility. We need to have both connection types there. So we've also got, basically, we need to have that data can either be on-premise or we can be in the cloud, or it can be a combination or a hybrid of both of those. It needs to be very scalable. Today's networks have to be scalable and cost-effective, and most of all, they're going to be future-proof. You know, then also we've got to have, as I mentioned before, we've got an IT-OT kind of a situation going on. Back in, you know, previous times, that those were 2 separate things. Well, now it's really becoming one. So that's got to be frictionless so that basically everything is now networking together, right? So when we start kind of now looking at this, and when we start making this leap now into this digital transformation, and we start looking at why are we trying to now modernize our network? And so today what we're looking at is we're going to try and look at when we want to modernize our wireless networks to increase our reliability for this connected enterprise or this network scheme. You know, this is going to be, you know, a reason maybe to upgrade that old system that you've got. So we kind of look at yesterday's wireless networks. We really had a series of point-to-point links out here where we defined a pathway in order to get to anything. So now in order to increase that reliability and bring stability to that network, this is really kind of what we're doing now, where we can create these redundant or backup pathways. And this is what we do when we start talking about a mesh network. Now there's different terminologies, but this has kind of become that generic term for for kind of that redundant, self-healing backup pathways that we can build into the network. And this is incredibly powerful because now all of a sudden when we have something, that it can be anything from a power outage, we have a storm that blows an antenna out of alignment. Now we don't lose the whole network. We simply move over, take the redundant path, and everything continues to work just fine. And before we get into kind of the nuts and bolts of exactly how that works, what I want to kind of look at is take a step back and say, okay, when we start talking about mesh, that can mean a lot of things. Like I said, it's kind of become a very generic term. So really when we look at this is where mesh came from is ultimately kind of a buzzword, right? So it really came from back in what was called the IEEE standard. It was an 802.15.4, better known as Zigbee. So the whole idea of this was that these could kind of daisy chain these little low power devices that could kind of daisy chain or repeat to each other in order to relay that information across a greater distance. That's where the term came from. Now, when we start looking at wireless or industrial mesh technology as it's applied today, and especially how Esteem is doing this, it's really built for a completely different purpose. It's really made so that we can have a self-healing, redundant backup communication paths that automatically switch. So if we have a bad path, we can switch this thing to a good path. Now, it's also used that we can now have a complete canopy for Wi-Fi devices. And so this is something that can actually be set up for, whether that's a thin client, we can have maintenance vehicles that are roaming throughout this, but now we can use Wi-Fi connectivity in order to bring it in across that whole network as well. At the end of the day, really what we're trying to do is to ensure that we've got data reliability between devices. At the end of the day, that's really what you, the customer, is looking for, or your customer is looking for, is that we can do that. And so what we do, or how we function with this, is it really uses just a very standard network protocol, spanning tree protocol. And there's actually 3 flavors of this that we support, which is spanning tree protocol, rapid spanning tree, and multi-spanning tree protocol. We'll get into that in just a minute on kind of how that functions. What's also a little bit different is that these routes that are done here in our primary paths and our backup paths is that those are configured, controlled, and prioritized by either the user or the integrator that's setting this up. And why we do that is in radio, a lot of times the shortest path isn't always the best path. Sometimes what we want to do is we want to get this, so we may want to go through a repeater as our primary path, but if something happens to that repeater, we want it to fail over on a direct link. Doesn't mean you have to do that, but we want to give you full control over actually doing that. And so this all happens in the background because essentially this self-healing really is what creates the reliability and the stability of that network. So as we kind of take a little bit deeper dive, we're going to kind of isolate this piece over on the left-hand side and how we actually do this priority routing. So when we start looking at this, when I talked about we can configure, control, and prioritize this, and this can either by the end user or either systems integrators, can do, and this can also be altered. So if things are changing, we may have trees that are growing up, we can also change this. But really what we're looking at is we want to have a primary path, and then we want to identify that backup path. So within our terminology, we're looking at what we call a path length, okay? And this all goes into the path costing of spanning tree protocol, is where it correlates to. But what we have tried to do is to put this down into something that we humans can kind of comprehend or easily navigate. So what you're looking at here is that by default, everything has a value of 1. So if we kind of lay this in, you can see each one of these links, you can see that purple value has a 1. So what we're looking at is the sum of that total path length. So when we look at this direct link over on the left has a value of 1. This one over on the right now, when we take that same path, we have a path length of 1, a second path length of 1. We add those together, so that's going to be a 2. So what this means is that we're now going to have is that direct link is going to have the lowest path length or path cost. associated. So it'll be set up as our primary pathway. If that link gets obscured, then it's going to actually move over to that backup path, right? Hopefully make sense. So now what we can actually do, and this is great because this is what is going to happen kind of by default. But as I mentioned before, what we want to look at is what if I want to force that to go through that repeater because it's a better signal, a more robust signal giving me better data rates, and I want it to be my primary path. Well, then we start, all we really have to do is to kind of take that same simple math into this and start looking, okay? Say default values are ones, right? We looked at. So really to accomplish this, so we've got a 1 and a 1, so we know that that is essentially our 2, correct? So now in order to basically make that our pathway that we want, or the shortest path, is that we now need to make this direct path higher number. So all we have to do is to now go in, and this is within the configuration of each link, is set its path length at 3. Right? Makes sense? So now we've got a 3 versus a 2, which means that that route through the repeater is the shorter path length or shorter path cost in the spanning tree world. So it's going to be our primary path, and now that backup path is going to be that direct link. Okay? So makes it very simple, but what we want is for you to be able to control who's the primary path, and you can do this all throughout your network. And so we can build that redundancy. And you don't have to have only a single backup path. We can have multiple backup paths. So we can build this as redundant as we need to. Okay, so as we kind of take this and kind of giving you a little bit of a sneak peek at actually as what is going on or coming up in the future, is that we also are going to get into what we call conditional routing or dynamic routing here. So what this is now going to allow us to do, and this is again coming soon, it's not within the current release of it. We're anticipating this to probably come out a little bit either at the tail end of this month or into June. But now what we've done, and this is actually a direct question coming from customers of, can we do this? Is now all of a sudden we can start looking at how do we control those routes beyond just path cost. So now what we're going to be able to do is that we have got a link threshold mode that can be enabled and turned on, and then think of it as we can now tune these links so that they can perform exactly like we want to. So what we start looking at here is what kind of things can we do? Well, now we can actually control what that signal threshold is in dB in order to bring that link up. Okay. We can also say how many packets do I need to have to bring that link up. So instead of it being the bare minimum, says I don't want this to be good unless we have a signal strength, say of a -70 dBm. Right? So now we can start to control that network. Now on the flip side of that, we can also set the threshold of what takes that link down and would force it to that redundant pathway. So if you get into something where we may have trees growing up, or we may get into a mobile meshing type of application, the other one that this is good is because signal strength and data rate are tied, is we can set a signal strength, says, okay, I never want to drop below this data rate for things like a camera application, something that is very time sensitive. So we can always maintain that highest amount of signal, which means the highest amount of data rate. Also control how many packets it takes to, say if I lose 5 packets, or I need 10, but we don't want this is rapidly flapping between the two. Say if we just get a reflected signal. So we can say, hey, if I miss 2 packets, 3 packets, whatever, this is something that you can actually configure. Then we also have a maximum packet loss in order to take that link down. So if we're getting good signal, just horrible packets, now we can take that link down and force it to basically to the other side or into that redundant pathway. Hopefully that makes sense. If not, you can feel free to ask a question or shoot us an email about this. And this is going to be available again, like I mentioned, towards the end of May into June, and this is just going to be on a firmware update. For those of you that have Horizons already, this is something that's a simple firmware update that we can do. And what it actually looks like in terms of setting this is kind of there's a little snippet here to where we turn that link threshold mode on, we set the values. You can see there we've got our link up threshold, link up packet count, we've got the link down threshold, link down packet count, or the link max packet loss. These are areas that you can actually go in and configure. This is real time, so you can actually make these changes, say as we start, maybe get something a little bit more time sensitive that becomes an issue. Now we can do that, okay? Again, this is something that's coming out in a firmware release, kind of targeting for end of May, first part of June. So it will be up on our website, or if you're interested, then we can definitely get you out a link to this. It's in kind of out doing some field testing now with some customers. Okay, so as we start looking at this, so this is kind of the how-to, right? So when we start looking at this, what is it actually doing? You know, how does this work when it's actually in motion? Well, what we start looking at is, okay, here's how we have this thing configured. So what it's going to do kind of in motion or basically in real world conditions is we've got basically our primary pathway here. Everybody's happy, everybody's communicating, and we may have some sort of an instance, you know, that the tank is going to be getting painted. So we, you know, the maintenance workers unplug that. So now we lose this one. So now that basically what's going to happen is it reroutes itself based upon that information that you configured for your path costing or path length. We're going to move over here. Now all of a sudden we may have another instance in which, okay, well, we're going to now, you know, something happens out at this location. Again, it's just going to reroute itself based upon how you have this configured and heal so that we maintain the communications to this. And it's just going to continue to work its way around. Maybe it's this one that we lose, and we can build this redundancy all the way through. Now we've got this. Okay. Now, one of the other key aspects to this that we want to make sure that happens is when these devices, say, take that same tank that may have been unplugged, now comes back online, we want to make sure that we now switch back to those primary paths, because those are the ones that we've identified, say in the site survey, these are our primary paths. So we want to make sure that when there's some sort of an instance or a failure, we move to the backup path. But then it basically, when the primary path comes back up, we simply move to it. Again, this all happens in the background. So it's going to be something that you don't necessarily have to manually adjust for. Once you've configured it, this all does it on itself automatically. So it's an automated process. Okay. So again, so what we're looking at there is ultimately, so the redundancy is going to build into that. Okay. So one of the big questions that we also get is, you know, how complex is this to try and get configured? You know, is this going to be something that's going to be very difficult? And absolutely not. So with all of our Horizon series radios, and I'll kind of touch on those in just a moment, is that there's two methods in order to configure these meshing links to this. Is we can go in and identify by MAC address which ones we want to do, and basically go in and hard code it into the radios. But we've also said, you know, let's make this easier. So what we've done is we've actually come out with what we call it the Esteemed Network Suite. What we can actually do is simply draw lines on this utility between the radios. That's all it takes to configure this. So what that's actually doing is configuring these primary paths, right? Okay, great. So now how about if we want to add in our redundant paths? Well, here we go. We just go in and simply do the same thing. We're going to draw the lines, all these different pathways that we can. Now we can actually go in and actually look at each one of these radios to kind of have a brief snapshot. But then we can open up each link. So you can see right there at the top is the path length. This is where we can start to alter that. So we can say this is going to be my primary, secondary. We can also control that things like the throughput rates, This is where we can set those, basically those new threshold rates are going to be within that, so that you can actually go in without ever having to go into the web browser and actually take this, configure this just between icons and channeling this, and then commit these configurations right to the radios from there. Makes it very simple, rapid deploy a network exactly how you want it. Okay. So this can also be something that we can send those firmware updates like I talk about. You can actually do this for this utility as well. This utility is available up on our website if you want to get it. You can also take and start to explore this a little bit. And you can actually plot in dummy radios. And so you can actually configure your whole network before you even order the radios, share it with us, and we can say, hey, this is a great idea. Maybe we need to look at doing this, but allow us to basically go in and kind of review that with you. Okay. Now, one of the other powerful parts about this tool or this utility is what we have that we've built in, which is the monitoring mode. Okay. So you can now also go in and monitor these links that we've got. So we've got this, we're talking about our redundancy. So what you'll see here is it's going to show us the signal strength. We're also going to get in the RF data rates, which is right here. This is how much data rate we've got on this particular link. Here's the other key to it that we were looking at. So in this one, this is our forwarding link. So think of this as our primary communication path going this way. And this link is actually being blocked because this is the longer pathway, right? And just like we saw in the diagram, but this actually allows you to do this. And this is real-time monitoring. And so you can actually go and look at this and see exactly what this, kind of think about this three-dimensionally. If we start to see, maybe we've got tree growth coming up. Now we can look at this and start to look at some trending. Maybe our signal strength is dropping because of those trees. Well, we may want to go in and change that so that maybe our primary pathway is now going through that repeater instead of direct. Again, you can do it right from the same utility, just going by and altering those path lengths. Okay. So kind of at least from that standpoint, it also shows that STP port status, right? Okay, so I kind of alluded to this Horizon series, and really what this is this is our radio that's basically our high-speed meshing radio that we've been talking about. And it's available at 900 megahertz. And kind of think about this. Now all of a sudden at 900 megahertz, we can do meshing across this. And oh, by the way, we can do it at up to 72 megabits per second of RF data rate. So it's absolutely something kind of a game changer in the 900 megahertz world. So we can get the Wi-Fi technology or speeds, but push this out at 900 megahertz. Now we also have this available in the 2.4 gigahertz. We also have this available in 5.8 gigahertz. So not only can we build these mesh networks, it also has Wi-Fi capabilities. So now you can bring in those, thin clients or your maintenance workers, or if you want to just hit this on your tablet or on your phone, we can not only build out that mesh network, but then also provide the Wi-Fi connectivity right through the same device. All of these are going to have that industrial mesh technology. Basically, we've got a single device that can go into multiple modes. So we can put this into a simple bridge. We can go into a router. We can go into masquerade modes. We also can put this into a station mode. And this is going to be typically more for your mobile clients, whether that be an AGV, we can get these speeds, but now we can roam between access points like a simple client. Supports both layer 2 and layer 3 networks. Very secure communications in that, and we'll touch at much greater length about that in another webinar that we're doing, but basically we've got AES 256 encrypted connections. So very secure, very reliable, and we've got the redundancy. I already talked a little bit about that Java-based utility, so very simple configuration. And we've also got a memory module inside the radio, so we can actually make a backup of that radio directly onto an external memory card in addition to the onboard memory. So if something were to happen in kind of in an incident, we can pull that card out, put it into a new one, and clone that exact radio and have you back up in no time. Makes it very, very rapid in terms of deploying it or replacing it. Okay, but we're kind of getting close to the end of our time here. But really kind of what we've got is we've got an entire series that we're doing on modernizing your wireless network. And you kind of see a schedule here. It's down in the handouts there as well. You can get, and it's up on our website. The next one we're going to be doing next month is going to be modernizing for that cybersecurity we were just talking about. Now, if you want a little bit of help going through this, not have to necessarily wait through them, up on our website, we've actually dedicated an entire section into modernization and the different reasons for it. So you can reach it by going under the solutions for Modernize Your Wireless Networks, where you'll see a big giant blue button right down here to modernize your wireless networks. And what that's going to do is to basically take you to these different sections. And so today we were talking about reliability. Last month we were talking about Ethernet. So you can actually go in and click on these boxes and take you to much more information to get you right to what you want. We realize that there's people that are modernizing for different reasons. Maybe they've moved into an Ethernet network. They just want a more reliable network. Maybe they've got a network that basically is very unsecure, and with cybersecurity threats of what they are today, we need now to boost up that security. So we kind of tailored this to really address what your needs are to get you the information that you need right away. Of course, you can always contact us as well. Hopefully you can join us next month when we actually get into this. We're talking about cybersecurity, which is going to be on June 22nd. And if you've got any questions, you can ask them here. If not, feel free to shoot me an email or you can give us a call. All of our contact information is also on the website. And with that, I would like to thank you for your time, and we have a great week, and thanks a bunch.